Hello everyone, my name is Vincent, and in this video we are going to talk about wave interference. So what exactly is wave interference? Wave interference is a phenomenon that occurs when two waves meet while traveling along the same medium. The interference of waves causes the medium to take on a shape that results from the net effect of the two individual waves upon the particles of the medium. To begin our exploration with wave interference, consider two impulses of the same amplitude traveling along the same medium. Let's suppose that each displaced upward 1 unit at its crest and has the shape of a sine wave. As the sine pulses move towards each other, there will eventually a moment in time when they will completely overlap. At that moment, the resulting shape of the medium would be an upward displaced sine pulse with an amplitude of 2 units. The diagram depicts the before and during the interference snapshots of the medium of two such pulses, because 1 plus 1 is 2, right? This type of interference is sometimes called constructive interference. Constructive interference is a type of interference that occurs at any location along the medium when the two interfering waves have a displacement in the same direction. In this case, both waves have an upward displacement. Consequently, the medium has an upward displacement that is greater than the displacement of the two interfering pulses. Constructive interference is observed at any location where two interfering waves are displaced upward, but it is also observed when both interfering waves are displaced downward. So it's not totally isolated with two waves going upward, but also going downwards. On the other hand, destructive interference is a type of interference that occurs at any location along the medium where two interfering waves have a displacement in an opposite direction. For instance, when a sine pulse with a maximum displacement of positive 1 unit meets a sine wave with a maximum of displacement of negative 1, destructive interference occurs. The interfering pulses have the same maximum displacement but in the opposite direction. The result of that is that the two pulses will completely cancel each other. When two pulses with opposite displacement, for example, one pulse displaced up and the other down, meet at a given location, the upward pull of one pulse is balanced, or cancelled or destroyed. By the downward pull of other pulse, destructive interference leads to only a momentary condition in which the medium's displacement is less than the displacement of the largest amplitude wave. The two interfering waves do not need to have an equal amplitude in opposite directions for destructive interference to occur. So for example, the pulse with a maximum displacement of positive 1 unit could meet a pulse with a maximum displacement of negative 2. The resulting displacement of the medium during complete overlap is negative 1. So by the word destructive, it doesn't necessarily mean that it destroys each other, but it's actually just cancel each other according to its amplitude. So in our example here, the red wave, which has 1 unit, the blue wave, which has negative 2 unit. When they overlaps, the result of the interference is the green wave, which is the negative 1. So positive 1 plus negative 2 is equals to negative 1. This is still destructive interference since the two interfering pulses have opposite displacements. The destructive nature of the interference does not lead to complete cancellation. Interestingly, the meeting of two waves along the medium does not alter the individual waves or even deviate them from their path. This only becomes an astonishing behavior when it is compared to what happened when two billiard balls meet or two football players meet. Billiard balls might crash and bounce off each other, and the football players might crash and come to a stop. Yet, two waves will meet, produce a net resulting shape of a medium, and then continue on doing what they were doing before the interference. The principle of superposition is sometimes stated as, when two waves interfere, the resulting displacement of the medium at any location is the algebraic sum of the displacement of the individual waves at that same location. Summing the individual displacement for locations of complete overlap was made out to be an easy task, as easy as simple arithmetic. So we have here the displacement of pulse 1, displacement of pulse 2. For the displacement of pulse 1 and pulse 2, we have 1 plus 1 is equals to positive 2. Negative 1 is equals to negative 2. That is in the case of constructive interference. For positive 1 and negative 1, that results to 0, and positive 1 plus negative 2 is equals to negative 1, that is a destructive interference. So that would be all for the wave interference. So I hope you learned something from this and have a good one. Thank you very much for watching. Bye-bye.